Hey there, this is Jacob from RoboFlow, here today for an object tracking tutorial. So object tracking is an extension of object detection. Detection is where you're able to identify objects in a given frame, and object tracking allows you to track the identity of those objects across frames, say like in a video. So if you want to like count the number of objects in a video, this is a very useful way to do that. You have to use object tracking. So for example, in this video here to my right, you can see these sharks and fish swimming across, and their identities are identified across frames. So this fish is being tracked throughout the entire video. Now we're going to dive in so you can do this with your own model on your own data set with your own custom objects. So let's go ahead and dive in. So I'll post a link to this repository. I'll also post a link to all the wonderful details on how this works. But for this video, we'll just go ahead and dive right into the code. And one other thing before we dive into the code is to look at this blog post here. This is how to implement object tracking, and this is all the same things that I'm saying in this video in a blog post. In case I gloss over anything or if you need a little bit more color, you can refer to this as well. So now let's go ahead and dive in and start coding. So this is RoboFlow's official object tracking tutorial. So to get started, all you'll do is you'll clone this zero-shot object tracking repository that I've just mentioned, and we can go ahead and change our directory to enter into it. Now that we're into this video, you'll see in this data folder, in the video folder, there are a few assets that we can use to test out our object tracking. So we'll just look at this cars video here. So if you go ahead and run these cells, you'll have to go through a Google authentication to be able to view the video. But this will send back some HTML so you can view your video in Google Colab. And one other thing I want to mention here is if you don't want to do this on cars and you want to do it on your own video, you can go over here into this folder area and click this upload button and upload your own video. Just make sure that you change the file path to the video that you've uploaded. And we'll go ahead and take a look at this video. So this video is basically a bunch of cars driving down the street. And so with this tutorial, we'll actually track these cars to see if we can make predictions on the cars and then be able to track them throughout the video. So the next step is to download Clip. So Clip is OpenAI's general zero-shot image classifier, and we'll be using it for our object features. Now, some of those wonderful internals I was talking about, usually you'd have to annotate your own stream of objects and train a classifier to identify your objects, but now you can just use Clip as a zero-shot featurizer, which is really nice, and we have that all implemented and packaged up into this repository for you. The next step is to install a few Python requirements. So these are all in our repository, and then also there's this FTFY package, which was causing us a little bit of heartache, so you have to install it independently. Okay, now we're ready to actually run object tracking. So here you have your clip object-tracker.py. You just point that at the source of your video. If you want to use the generic Yellow v5 Coco trained, the common objects model, you can just use this exact script. Otherwise, you can point this with -- weights at your own weights. Other detection engines that you can use the RoboFlow Inference API. So this is if you've trained a model with our AutoML training solution and deployed that with our kind of auto deployment solutions on RoboFlow Inference. There you would just put your URL here, your model URL, and you would put your API key here, and then all the detections will be happening up on the API, while the clip featurization for your objects and the deep sort algorithm will all be running here in this notebook. One other venue that we'll have here soon is Yellow v4. So now you have Yellow v5, RoboFlow Inference API, and soon Yellow v4. So to run this, you go ahead and hit Python clip object-tracker.py. This will go ahead and initialize the models, that is both the clip model and the Yellow v5 model. These models will be running on the stream of your video, so your video will get parsed into a stream of frames. Each one of those frames gets passed through the detection script, and you'll see the detections being made here on the frame. So in this frame, it saw 9 cars and 1 truck. And now these objects will be passed through the featurizer. Those featurizers will be getting compared, and the objects in each frame will be getting compared for similarities. All this will be happening through the deep sort algorithm, like I mentioned. And you'll go ahead and process through the whole video here. And then once you're done, you'll see your experiment come out here in runs, detect, X, and then your video prediction output will be here. And so you can see that here if you go into runs, detect, and then the experiment. So the number of experiments that you run will kind of add on sequentially here. And now you can go ahead and download this. If you want to view it, you can download it here. Or you can use this little fancy script here that I've given you to download the video file. So I also already have this pre-baked. So we'll go ahead and check out what inference looks like here. So here's those cars driving down a road, like we mentioned. So you can see here the car detections are being made, and you can also see that it's doing quite a good job of tracking these objects throughout the frames. So that's pretty much all for our tutorial here. It's honestly ridiculously simple now to do object tracking now that we've implemented zero shot. So the zero shot should work pretty well for your objects. There could be certain scenarios where it might be the case that you still need to fine tune a featurizer, like maybe if you're using some obscure machine parts on an assembly line, something that isn't images that aren't generally out there on the web. But otherwise, this pretty much should do the job very well for you, and we hope you enjoyed this video on learning how to track your custom objects with your custom object detection model in just a few short lines of code with a nice Google Colab that you have available for your own usage. So if you enjoyed this video, please like and subscribe, and as always, happy training, happy inferencing, and now, most importantly, happy tracking. So thanks so much, and see you in the next video.